All right, listen up, listen up. So we're going to kind of, for our notes to help remind you how to do this stuff, we're going to go over question 1 and question 2. Okay? So if you look at the first one. Square root of 125. Now, one rule that you learned in algebra with square roots is that if we have 125 times 10 inside of our square root, we can split it up to be the square root of 125 times the square root of n. Okay? So that is a rule that you looked at in algebra. Another rule that you looked at in algebra, and that will not be our first step. I'm just going over a couple things real quick. So you can write that down if you want to. Another rule you looked at in algebra, and this will come into play more in the next worksheet, is if we have like the square root of 7 over 10, we could rewrite this as the square root of 7 over the square root of 10. Okay? Do we remember looking at that before, or is that totally like, oh, I've never heard of that? You've seen it before?
I've seen it, but I don't have it.
Okay. Yep, that's why we're going over it. Now, another thing with square roots, if we look at this, it would be called the product rule. Here's the quotient rule. We could do like the inverse of the product rule. So if we had the square root of 125 times the square root of n, we are also allowed to write that all under the same square root. So it works both ways. Okay? So those are a couple rules with radicals and the square roots that we need to be aware of. Oh, there it is. But the other thing that we need to be aware of, which will come up in the second worksheet, is that when we have a square root on the bottom of a fraction, we don't like square roots on the bottom. Okay? So in order to get that square root to the top, we need to what's called rationalize the denominator.
I just learned about that.
So we multiply. What is square root of 3 over square root of 3? What is its value, actually? It's just 1. We know that anything times 1 just gives us that anything back. So we are allowed to multiply by square root of 3 over square root of 3 so that we can get rid of this square root of 3 on the bottom. So root 3 times root 3 just gives us 3. And then 1 times root 3 would just give us root 3. Okay? So you won't see it on that first page, that first worksheet, but on the second one that I'll give you, it'll say the directions will be rationalize the denominator and simplify. So our answer cannot have a square root in the bottom. Okay, the way we call it rationalizing the denominator, but that just means that we multiply by that square root over the square root. Okay? So that's kind of the introduction to everything. But that's everything you need to know. That's like that's 3 lessons of algebra in 3 minutes and 33 seconds. So good job, everybody. Now, if you look at that problem in number 1, you have the square root of 125n. Now, what you learned about in algebra is the idea of perfect squares. Okay, I wrote the first, and Zach, I guess, helped me out with 13, or with another one. But I wrote a bunch of the perfect squares up on the board. So, like the square root of 4 is 2, 9 is 3, 16 is 4. And like 4 would be considered a perfect square. 9 is a perfect square. 16, perfect square, and so on. So when we have a number in under our radical sign, under our square root, we want to see, first thing, if it's a perfect square. Because if it's a perfect square, we can take the square root of it, and we're all good. So it's 125 a perfect square. Nope. So the next thing we want to look to do is write 125 as the product of a perfect square and another number. So if we look at our perfect squares up there, what's the largest perfect square that goes into 125? 11. Well, that doesn't, I see what you're getting at. But what is the largest perfect square that we can divide 125 by? Right, 25. So we could rewrite 125 as 25 times 5 Now because of our one of the rules we looked at earlier, the product rule, this would be the same thing as square root of 25 times the square root of 5n, and we can just simplify the square root of 25. Now we look at our number that's left over in our parentheses, or our exponent, nope, in our square root, there we go. And we see if there are any other of those perfect squares, 4, 9, 16, 25, that can evenly go into it. We see that there is not, so we know that it is all the way simplified. If we had to rate ourselves from 1 to 10 for how much we remember from last year, where would we be at right now?
I guess.
The only thing I remember about
I
how
never
much I
learned
hated
this
it.
last year.
The only thing I remember.
That's a 10 out of 10.
Zach, we did learn last year. You didn't pay attention.
What, were you online?
Yeah.
Yeah, that makes
We
more sense.
started it like right before. It was so hard.
That makes more
Well,
sense.
like I said, today we're just reviewing it, so hopefully we can fill some of those cracks.
To answer your
Yeah,
question,
if it was
it was
online, they
6%.
didn't require us to do it, so I did.
Let's look at number 2. Square root of 216. Or sorry, let's look at number 3 because that has variable that's 512. Correct. So the first thing we want to do is we want to look at 512. What perfect square goes into? What's the largest perfect square that goes into 512? We might have to do some guessing.
144.
All right, try it. Let's go. Get our calculator out. Try it. Find the largest perfect square that goes into 512.
Can I use my phone?
No. You know the answer.
Oh, there you are. Oh yeah. Yeah, I got us. Fuck. I'll send you. I had a phone call with her for 45 minutes. So what?
So,
Because I got the zero. Because I crushed it.
hey. So, hey, listen up. Zach found that the largest perfect square that goes into 512 is 256. Okay, so the square root of 256 is 16. So 256 goes into 512 2 times. So we rewrote that as 256 times 2. Square root of 256 we can simplify. Now, is there anything else we can simplify? Yes. So that would be all the way 16. Now, I don't think in algebra that you use variables.
No.
Yeah. Oh, sure.
Why would
Further?
the case come instead?
Why would what? So, like, here, with the square root of 256, we know what that is.
Yeah.
It's 16.
Yeah.
So we can just write it as 16. Anything, k squared, if we square root, it'll just give us,
The square root and the
The
times
square-
two.
they
Yeah,
are,
the root is the inverse of the square. Does that make sense? So they cancel out.
Yeah.
It's like,
How do you
do we want to look at one more example?
Yeah, one more.
Let's go with number 2.
What do you get? You need a good one?
Probably lose.
So, let's look. What is the largest perfect square that goes into 216?
Probably 36.
We're checking.
Just a guess.
The largest perfect square.
Check that.
Well,
out.
you're right, it does
Yeah.
Is it 36?
I think it's 36.
Okay, 36 times what?
I hate to guess and check.
You have to,
It takes too long.
well, you don't have to check all of them.
36 times 6.
Now we know, it's not, we know we're gonna take the square root of 36, that just gives us 6, and the parentheses left, they're in the square root left over. It's 6 feet is 32. Now, let's say, look, let's say, how many times does 4 go into 216?
15, maybe 20.
Somebody check. 54? Let's say we didn't get the largest perfect square. So we know square root of 4 is 2. Well, now we can look at 54 and we think, is there another perfect square that goes into 54? I think 9 does. 9 times 6. Then you get 2 to 6. Then we have 2 times
It
square
still
root.
ends up as 6.
Right, still ends up the same. So even if you don't get the largest perfect square, you still can get your answer.
That's sick of mine.
Got this. Yeah. So here's, like I said, I'm not trying to like make you go crazy, get you super frustrated. I just want to review something that will be helpful for you in geometry B. So even if we don't get every single problem, but if we can kind of get this idea back in our minds, what we're supposed to do with these square roots, and that'll help you a lot. So here's the assignment for the next